Chapter 6.5, exercise 7 through 12. This set of exercises has to do with graphing polar equations, and this is a follow-up to my last video lesson that covered problems 1 through 6. These exercises presume a more in-depth knowledge of certain identities of trigonometry than we've actually covered this year. And so mainly we're going to be graphing to test our answers using a graphing calculator, TI-Inspire CX calculator. In exercise 7 and 8 refer to the curves in the given figure. We have graph A and graph B. Problem 7, the graphs of which equations are shown. We have r sub 1 equals 3 cosine 6 theta, r sub 2 equals 3 sine 8 theta, and r sub 3 equals 3 times the absolute value of cosine 3 theta. And I believe I know which one it is already, but we're just going to pretend like we don't know. I'm going to put r sub 1 first, check on that. And we go to the calculator. To graph the polar equation, we go to Menu. We go to Graph, Entry, Edit. And in my operating system, my option 5 is polar. Yours may be option 4, but just look for polar, whatever it is. And then we're just going to enter the function here, which is r cosine 6 theta. So I put, let's see, 3 cosine. So 3 times trigonometry cosine, and we put in 6. Now I put in theta. And to get to theta, I press the pi key in the lower left, and I get this submenu, choosing theta here. I'm going to adjust the window. We have a limited window setting. I go to Menu, Window Zoom, Window Settings, press Enter. We're going to have an x maximum of negative 4.7, or x minimum rather, x maximum of 4.7, and then a y minimum of negative 3.1, and a y maximum of 3.1. Tab down to OK, Enter, Enter. Wow, that's a lot. And so what the principle is, we have the function, our polar equation is r sub 2, it's, well, r sub 1 really, 3 cosine 6 theta. What you're, in a rose petal, when you have an even number inside the argument for cosine or sine, you're going to have 2 times that even number. So we have 12 rose petals. So obviously that is not a correct answer. So let's go ahead and look at this other option. I'll go to Tab. I'm going to go enter this last function here, 3 times the absolute value. To get my absolute value bracket, I press the key next to the 9. And I go down here. Okay, we have an absolute value bracket in which we are going to place cosine. And as the argument here, we're going to put in 3 theta. So 3, and I'm going to go to this pi symbol, theta. There we go. That should be it. Press Enter. There we have it. So we have a 6 petal rose, similar to how graph B is. And so we will say this is graph B. Now what it is, you have this, you have a odd number 3, so that's going to give us just 3, but we have that absolute value. The absolute value, just kind of by reflecting, gives us, it's going to give us 6 petals. So that's how we got that. So let's go ahead and we'll say graph B. And then 8, use trigonometric identities to explain which of these curves is the graph of r equals 6 cosine 2 theta sine 2 theta. I happen to know which one it is, but I leave that to the viewer to go ahead and work that out on your graphing calculator to see if either graph A or graph B. Let's go on to the next set here. Next size is 9 through 12. Match the equation with its graph without using your graphing calculator. Now, I explained to you just a while ago that my plan is, for as far as we're going, to actually use a graphing calculator for this. And I'm going to explain a little vocabulary as we go, in that this is a shape, a type of shape called a Limassol. Let me write it down so I hope it's legible. Limassol. And there's going to be a little cedilla under that C. This is a French word that is an old French word for snail. And so I guess they're saying that these things look a little bit like shape of a snail. And yeah, I can see that. But the different types of shapes of limassons are here. This one here on the top left is called a cardioid. Now, why was this called a cardioid, do you think? And the upper right is also called a cardioid. Cardioid. And I think I misspelled that first one here. Let me get that fixed a little better. And why do we call these a cardioid? I believe it's because of the heart shape. Cardio, related to heart. And this one in the lower left, this is a limassol with an inner loop. Okay, and then the one on the lower right, this one is called a dimpled limassol. And in addition to these three types of limassons and these four graphs, there's another one called a convex limassol, which is just kind of flattened on one side. This dimpled one looks kind of like an apple shape. Anyway, we'll go over problems 9 and 11. Does the graph of r equals 2 plus 2 sine theta or r equals 2 minus 2 cosine theta appear in the figure? Explain. Well, let's just go ahead and graph and see if they do. I'm going to go to tab, come up here, and we're going to have 2 plus 2 sine theta there it is, and I think everything's right, and we're just going to enter, and that one here, this one here doesn't look like much like the other ones. Let's see if this is a, yeah, it's a cardioid, but it's a cardioid sort of upside down heart shape, and that's not like the graphs of the A or B, graph A or B. So let's go ahead and take a look at the other choice given. And that's going to be 2 minus 2 cosine theta. So minus 2 cosine theta. And we'll press this here over to, there we go. Let's enter. There we go. So this one here is really going to look quite a bit like graph B. And to explain, well, the thing just matches. So we'll say yes. And that would be R equals 2 minus 2 cosine theta. One thing you have here for these, if you have a 2 plus or 2 minus, and the coefficients are the same. You have 2 minus 2 or 2 plus 2 or 3 minus 3. Okay, that's what you'd get for a cardioid type of Limassol. And explain, I'm not going to explain other than this was graphed and this is what we found. Now we're going to go to the last odd number problem, which is 11. Is the graph in A the graph of 2 minus 2 sine theta or 2 plus 2 cosine theta? Well, I'm going to try to bring a little bit of understanding here. I'm thinking it's this one here. Okay? And what is my understanding of what that is? Why do I think that is the case? Well, I'm going to graph the thing first and then explain, and I'd like you to be thinking about that a little bit. So we go to tab, we go up, over here. Okay, this one here, the cosine one, is the one I think it is, the second one. So I put, no, I want the sine one, right? I think it's going to be the sine one. So I'm going to put 2 minus 2 times sine theta. There we go. And that looks more like graph A, except the window is not the same. I'm going to adjust the window like they have the window adjusted for A. We go to window zoom, window settings. We've got to change the Y here. We're going to go from negative, Y minimum of negative 4.1 to Y maximum of 2.1. Okay. There we go. And that's going to match graph A. So we'll say R equals 2 minus 2 sine theta. Now, I already predicted this. You saw me do it live. Trust me that I didn't check in advance. Well, the reason is when you have a cardioid or type of polar equation that is going to be with sine, you're going to be talking about a vertically symmetrical type of a graph where the y-axis is going to be an axis of symmetry, and as opposed to a cosine based type graph like of 9 where R equals 2 minus 2 cosine theta. And that is going to be the graph, let's say graph B up here. Yes, graph B, yes. And A is already answered. We answered A is going to be this one. So work out these other problems, 10 and 12. They should be pretty easy. I'm not trying to get too detailed. Mainly just getting experience graphing a little bit, and a little bit of vocabulary. Limassols, rose curves, and so forth. I hope this has been helpful. Good luck, and thanks for viewing.